All right, let's use a little simulation program. I got to thank Dr. Julia Friedman Silvernail for finding this and showing this to me. It's really a neat way to explore the mathematical relationships between position, velocity, and acceleration. These three parameters are key to understanding kinematics, the study of motion without regards to forces causing motion. It's important to recognize that each of these parameters are very tightly linked mathematically. And you have some equations to calculate velocity from position data and acceleration from velocity data and things like that. And we can, excuse me, the neat thing about these three parameters is not only are they linked mathematically, but each parameter gives a little different insight into the movement that's happening. And sometimes we really just want to know position information. Sometimes it's better to look at the velocity information, and likewise, sometimes it's important to look at the acceleration information. And to really understand what each of these plots and each of these parameters gives us, we need to do simulation exercises like this. So this is a program. You have the link in your assignment document. And just some things to look at here. You have two tabs up here. You have introduction and charts, and we'll go through both of these, okay? And now you have different things, you have different objects here, and we could obviously describe, have this person move towards the tree or towards the house or to a brick wall or what have you. And then you have this reference frame here, and obviously the person's starting at point 0 on the reference frame. So this is a horizontal axis. We don't have a vertical, nor do we have a medial lateral. But we've got 0 here, and positive direction is moving in this direction, and negative direction is moving in this direction. All right, so we got -2, -4, -6, +2, +4, +6. Always good to orientate yourself with the reference frame that's provided. And then we've got the three parameters here: position, velocity, and acceleration. Down here you have some buttons. You clear, which resets everything or clears what's up. Sorry, it clears what's going on in this image. You have a record button and a playback button. So you can actually record something and then play it back. And I'll show you that in just a second. Obviously, some playback button controls here. Then a reset all, that resets all these parameters. And I guess you have sound or no sound. Over in the chart side, you've got the same reference frame here, the same objects, the same person, but now you have plots, position, velocity, and acceleration versus time on the x-axis, okay? And then you can change each of these parameters by moving this arrow, or you can enter some information in here, and then you can actually have the simulation show the vector. All right, so I'm going to hit reset all here just to get that all back to 0. I'm going to go back over to here. And what I want you to do is to just try moving the person around and then watching what happens to the parameters down here. So you can drag the person, you can move the person over to the house, you can move the person back, and notice that the velocity and acceleration bars are doing something, okay? All right, so I'm gonna hit clear. Whoops. Oh, I guess I can, oh, it's recording there. So, all right, I could do playback, and I already messed up, but all right, let's reset all. And I can have the person walk to the house, walk back, stop, walk to the tree, walk back, and stop. I hit pause. And now I can hit playback. And now I can replay what I just did in terms of moving the person. And you can see the bars are moving. And it's good to just get a sense of why the bars are moving their way they're moving. All right, so let me clear that. Let me reset all. And I can also set the velocity to some number. All right, 0, starting at 0 position. It's going to start off at 2 meters per second and leave that at 0 acceleration, which means constant velocity. And then I think I can hit the play button here, and that's what the person does. All right. And then I could change the velocity, maybe go -2 meters per second. And now that's what the person does. Now notice the position's changing, the velocity is constant, and acceleration remains 0. That's because acceleration simply tells us how fast velocity is changing. If velocity is not changing, acceleration is going to be 0. Remember, 0 acceleration does not mean no movement. It simply means constant velocity. In this case, it's constant and -2. So what's the negative sign telling us? It's telling us that the person is moving from right to left on this plot. All right, and that's exactly what's happening here. Okay, now if I do playback, I'll do that again. So +2, the positive sign means the person is moving from left to right, which is exactly what's happening. And then I switched it to -2, and now the person's moving from right to left. Notice that the person is still on this side of the reference frame, on the positive side, but the negative sign is simply indicating that velocity is headed, that the person's headed in that direction, in the negative direction. Again, 0 acceleration throughout this entire period. All right, now I'm going to hit clear. I'm going to reset all. And now maybe I'll try some acceleration. Let me go to 1 meter per second squared. So if I set this to 1 meter per second squared and these two things at 0, in your mind, you want to start saying, okay, well, what's going to happen? This is going to tell us that velocity is now going to change 1 meter per second every second. All right, so let's see what happens when I hit play. And look at what's happening. 1 with the person, and then 2 with these two parameters. So let's go back, and I'm going to hit play again. I'll look at these. So look what's happening to velocity. It's getting faster and faster and faster and faster. It's getting faster at a rate of 1 meter per second every second. And so position is also changing. I can clear that and play it. Oh, I messed up. I lost it already. Position is also changing at a certain rate. So let's, and it's exponential at that point. Let's change this acceleration to, let me reset all. I gotta keep remember to doing that. Let's change it to -1 meter per second. Now in your mind, starting at 0, 0 meters on the position scale, 0 meters per second, what's gonna happen if you set acceleration to -1 meter per second? That's going to tell us that velocity is changing at a rate of -1 meter per second every second. All right, so now we hit play, and now we're seeing velocity increasing at a rate of -1 meter per second every second. And the person in this case is moving right to left. Why? Well, it does not have to do with this negative sign on the acceleration vector. It has to do with velocity being negative. In fact, let's change this. For example, if I give the person some initial velocity, let's give it 4 meters per second, and I give -1 meter per second squared acceleration, now what's going to happen? All right, so now we're starting at 4 meters per second, and acceleration is going to change -1 meter per second every second. So we should actually be seeing the person slowing down while moving forward. Oh, there he goes, he's slowing down. All right, now there's some other things changing direction. I'll get to that later on when we do some more PVA type of work. So bottom line, play around with these different parameters, try different things, and really try to deepen your understanding of the relationship between these three parameters. Let me clear, reset all. Let's go to charts. This is a really powerful tool as well, in that we can set up the graphs in a particular way to yield a particular movement. So let's see, can I move the person here? Yeah, I can. So I can move the person over here and look at the plots change, all right? So I move the person from 0 all the way over to the house, and that's reflected in the position. Because the person was moving from left to right, velocity is positive. There's something weird here, and that's just me sort of hesitating with the person. Let's see if I can do it again a little better. Reset all. All right, so if I go slow, fast, stop, I move from the zero position all the way over to where the house is and start standing still. Velocity was all positive because the person was moving from zero, well, excuse me, was moving from this position, and I don't care where it is, he's moving from left to right. He's moving in that direction towards the house. And the person sped up and then slowed down. And now look at the acceleration. It's a little messy because I'm sort of dragging the person. In anywhere where velocity versus time has a positive slope, acceleration's positive. Anywhere where velocity versus time has a negative slope, there's negative acceleration. Don't worry about how acceleration's changing yet. We'll do that later. That's a deeper understanding of acceleration that we'll eventually get to. But in essence, and you can see even as I'm doing this, when we look at how acceleration is changing versus time, it's a new parameter called the jerk, and it actually describes how smooth the movement is. All right, so let's clear, let's reset all. So that's one way you can drag the person. You can also change the vectors by changing this arrow here, okay? But let's just start with some zero. Let me reset. I hit play, and the person stands still for a period of time. Velocity is zero, and acceleration is zero, not because there's not movement, but because velocity is constant. Now let's make the person move from left to right. So if I do that, I have to make the velocity vector some positive number. I've just dragged the arrow up to be that. I could actually show the vector here too, right? Yeah, there it is. So I'll hit play, and now the person's moving from left to right. Why? Because I set the velocity to be positive, in this case, 2.222. Notice this little spike in acceleration right here. That reflects that little change in acceleration, or excuse me, change in velocity from 0 to the 2.222 meters per second. Notice that that slope is positive and acceleration is positive. But when velocity is constant, acceleration is 0. Remember, zero acceleration does not mean no movement. It simply means velocity is constant. And now we get some change in position up here. Now I can go in the other direction. I can drop this vector down. Oh, wait, we got to get the person to slow down first. So we went from 2.2. Let's have the person slow down to 1.6. All right. Now the person's velocity is slower. We had a little bump in acceleration, but wherever velocity is a flat line, wherever velocity is constant, acceleration is going to be 0. And we get just a little bit of acceleration where we had that change in velocity right there. Why is it negative? Because the slope of the velocity versus time plot is negative. The person's still moving forwards. The person's still moving from left to right. But now let's bring the person to a stop position. I'll make it 0 velocity. And again, one more bump in acceleration. Why? Because there's a negative slope in the velocity versus time plot. These spikes are really steep because I'm doing an instantaneous change in velocity, and instantaneous changes don't happen in real life. But for the purpose of this graph, at least it gives us the direction of the acceleration vector in that period. Now let's start moving from right to left. What direction do I need to make velocity? I need to make that some negative, and I can type a number in here. Let's make it -2 meters per second. What's the negative sign tell us? It tells us we're moving in this reference frame from right to left. If you watch the car speedometer video, it would mean that we were in reverse gear and stepping on the gas pedal to go 2 meters per second. And there the person goes, moving from right to left, going from a position over here, 5 meters, we were started about 5 meters, and then moving in this direction. And that will continue to move in that direction even if we go beyond 0. There's 0, okay, crossing the origin of the reference frame. And now we're moving still from right to left, but now we're moving with positions that are indicated as negative on our reference frame. The whole time moving -2 meters per second. What does the negative sign tell us on velocity? It simply tells us the direction of motion. And that's an arrow there. If you can't see, maybe you can see it when you do your simulation. It's an arrow there pointing in from right to left. Acceleration 0. Why is it 0? Because velocity is constant. The person's moving. 0 acceleration does not mean stop position. 0 acceleration does happen when velocity is constant and 0, but that's only a special case of 0 acceleration. So let's see, I recorded all that. I guess I could hit play too, and then I could work through what's happening. Oh, there's the velocity vector. And I really think this is sort of fun. Spend 30 minutes just going through different scenarios. And in the assignment document, I actually do have some exercises that you can try. Let me figure out where I'm at here. I'm on multiple screens. So this is assignment 3. And you've got these videos to watch. I've got the speedometer video that I mentioned here, PVA, position velocity acceleration graphs. And then for the movie man, here's some things to try and continue to work with different scenarios beyond this. All right, this is that immersion type learning. But see if you can answer some of these questions relative to the graphs provided. And if you can't, jump on a Zoom room and we can talk through some of these at a deeper level. Okay, so that is the Movie Man, a little simulation and sort of a fun thing to work through. Again, work towards understanding the relationship between position, velocity, and acceleration. All right, I hope that helps. Thank you.